Hello, welcome back to our little corner on the web, where we hope to encourage and nurture a love for math. So with all the views we're getting, we're seeing that a lot of people are interested in the qualifying stage questions. So we're going to hope to find some time here to provide you solutions to the 25th PMO qualifying stage. Thank you to the organizers for freely sharing the questions for the qualifying stage as well. So the first question in the 25th PMO qualifying stage states that how many four-digit numbers contain the digit 5 or 7 or both? Okay, so one way could be to build the cases for digits containing 5, containing 7, and then subtracting the overlaps. But the easier way would probably be to solve for the complement of what's being asked here and just subtract it from the total possibilities. So first, let's solve for the total possibility. So there's 4-digit numbers. And the first lot, we have a total of 9 possibilities, everything excluding 0. The next lot, we have 10 possibilities. And the next 2 other slots, we have also 10 possibilities. This gives us a total of 9,000 4-digit numbers. Okay. So the question is, which of these 4-digit numbers does not include 5 or 7? What we'll be left with will be the ones that have either one or both of them or multiple copies of both of them as well. Okay. So to prevent picking 5 or 7, really for the first lot, we have 7 choices, basically everything except 0, 5, or 7. And for the next 3 slots or 3 digits, we each have 8 possibilities. Okay. So if you multiply that out, 7 times 8 times 8 times 8, you should get 3,584. Okay. So we just subtract basically the cases that we don't want from the total number of cases, and we get 5,416. So the answer is A, 5,416. Okay. So question 2. Question 2 asks, let O be 0.00 and A be 0.01. Suppose a point B is chosen uniformly at random on the circle x squared plus y squared equals 1. What is the probability that triangle OAB is a triangle whose area is at least 1/4? Okay. So we know that x squared plus y squared equals 1 is basically a unit circle that starts at, or that has a center at 0, 0. So we can draw sort of a unit circle like this, right? And we know that point O is at the origin, and point A is at x equals 0, y equals 1. So point A is here. So the base of our triangle is 1, if we let the base be AO. So we know that the area will be equal to 1/2 base times height. So we want that to be at least 1/4. So B is AO, which is 1. So H must at least be a half. H is greater than or equal to 1/2. Okay. So H will be this perpendicular line. So we can let H be some line that's going this way. And all the lines that are below it and all up until here will be what we want. This is the range of what we want. Okay. But if the height is 1/2, we can draw a right triangle with radius 1, 1/2, and this height, I didn't draw it to scale, should be √3/2. Okay. If the base is 1/2. If you remember your 30, 60, 90 triangle, that basically means that this angle here must be 60 degrees. And this angle up here is 30. So the allowed or the desired points is included in some 120-degree angle, 120-degree central angle over there, and also 120 degrees on the other side. Okay. So basically, there's a 240-degree the desired angle where we can choose from is 240 of the 360-degree angle within the triangle. Okay. So that means that there's a 2/3 chance of picking B such that the triangle will at least have an area of 1/4. So D, 2/3. Okay. Okay, moving on to question 3. Question 3 states, suppose A1 is less than A2 is less than so on and so forth until A25 are positive integers such that the average of A1, A2 through A24 is 1/2 the average of A1, A2 through A25. What is the minimum possible value of A25? Okay, since we want to minimize it, we can set A1 through 24 to be the minimum they can be. So this would be, since they're all positive, being A1 equal to 1, A2 equal to 2, up until A24 is equal to 24. The average of this series is no more than the sum divided by 24. The sum, if you remember it, can be simply stated, because this is an arithmetic series, as the first term plus the last term, which is 25, times the number of terms, which is 24, over 2. Okay, so the sum is no more than 300. Okay, so the average is divided by 24. Okay, which is 12.5. Okay, so now we know that A1 through 25 has to average 25. Okay, so that means that if the average is 25, the sum from A1 through 25, if the average is 25, it's no more than 25 times 25, which is 625. Okay, but we also know that the sum from A1 through A24 is 300. So we just subtract 300. Therefore, A25 has to be equal to 325, or letter D. Okay. Hope you find these solutions helpful and educational. If you did, do hit the like button and subscribe. Thank you for watching.